Let's find the domain of logarithmic functions. For example, find the domain of natural log of x minus 2. Well, we know inside the parentheses affects the x, and it's crazy, cuckoo, bizarro, bonkers. So x minus 2 is going to shift our graph 2 to the right. Here's the easy way. We know whatever we take the argument of, whatever the argument of the log function is, must be greater than 0. So take whatever is inside the parentheses, x minus 2, and make that statement. It must be greater than 0. Subtract 2 from each side, and x is greater than 2. So the domain here is 2 to infinity. Let's look at what the graph of this looks like. Of course, our parent function here in black is going to look something like this. This is y equals natural log x. It goes through 1, 0, and e, comma 1, and it has a vertical asymptote at x equals 0. Now, if we're going to move this 2 to the right, then our asymptote here, x equals 0, becomes x equals 2. And our graph, I'm not even so concerned about my points right there. I just want a sketch of it. Well, of course, if I move it to the right, it will be 3, 0. And then this will be 2.7 plus 2. And that's about 4.7 comma 1. And so we can see here, if my domain was 0 to infinity, my new domain will be 2 to infinity. But don't include the 2 because we have this asymptote here. If I do put a 2 in here, then I'd be taking natural log of 0, which has no solution. Oh, all right. Finally, thank you for challenging us, Ronnie, with a little bit of a more difficult problem. Find the domain of this. Now, of course, this can be written as g of x equals natural log of negative x plus 2. And so if we're listing our transformations, home run, Svetlana, victory. Easy for me to remember this mnemonic device. I'm going to first do a horizontal translation. A plus 2, well, inside affects the x. It's crazy, cuckoo, bizarre, bonkers. I'm going to move everything to the left 2. So I know that goes left 2. Inside affects the x. So a negative on the x is going to take a positive x and reflect it to the negative side. So we have reflection over the y-axis. And we have no stretch or shrink and no vertical movement. So I want to first draw a sketch of my parent function. There it is. Here is y equals natural log x. And so it's going to go through this point 1, 0, and then of course also e, comma 1, and it has this x equals 0 vertical asymptote. So let's first move this to the left 2. If I move everything to the left 2, I'm going to be out here, somewhere out here. Here is x equals negative 2. That is the new vertical asymptote. And 1, 0 will now go at negative 1, 0. I moved it 2 to the left. And E1, well, that's 2.7, comma 1. So now that's going to be just 0.7. If I subtract 2 from about 2.7, I'm going to have 0.7. And so here is a sketch of my graph. Now this is this is y equals natural log of x plus 2. I now have to take this and reflect this over this y-axis. So if I do that, if I'm now reflecting it, x equals 2 will be here. Here is x equals 2. If x equals negative 2 is reflected over this y-axis, it's now going to be x equals 2. And this point, negative 1, 0, is going to go to 1, 0. And so this point will go here, and it looks something like this. And there is my graph of natural log negative x plus 2. So what is its domain? Well, I'm looking at this graph here. The domain is from negative infinity all the way up to 2. Can I include the 2? No, sir, I cannot. No, ma'am, I cannot. So as a review, I had two transformations. Move it to the left 2. I do that first. HRSV. Horizontal, reflect, stretch or shrink, vertical. For me, it's home run, Svetlana victory, as an ode to my high school girlfriend, Svetlana. And she used to always cheer for me when I would hit home runs on the baseball team. I'm going to move it 2 to the left, and then that gave me this graph here, and then I reflect it to give me negative infinity all the way up to 2. Don't include the 2. What a great problem. Thank you, Rob. I loved graphing that last problem. What if you wanted to find the domain without graphing it? You know, whatever we're taking the natural log of has to be positive. So you can mechanically set this up and then say, well, subtract 2 from both sides. Negative x is greater than negative 2. And if you divide both sides by negative 1 or do a commensurate multiplication on both sides by negative 1, remember you have to change the sense of the inequality, which means you'd have to do this. So either way, probably much more simple this way to say that the domain here is x is less than 2. That means x can come from negative infinity all the way up to 2. And you get the same answer. Wow, here's when we really have to think on. What is the domain of natural log of x squared? My argument is x squared. Well, mechanically, I know whatever I'm taking the argument of with the log problem must be greater than 0. So what values wouldn't give me a value greater than 0? Well, if I put in a negative 1 and I'd squared, that's certainly greater than 0. How about a positive 1 squared? Well, that's greater than 0. How about negative 2 squared? Well, that's greater than 0. How about 2 squared? Well, of course, that's greater than 0. What's the one value that won't give me a result greater than 0? How about if I put in a 0 for x? Is 0 squared greater than 0? Is 0 greater than 0? No. So the domain of this is all real numbers. If I'm doing a number line, it looks like this. It's all real numbers except for 0. How do we interpret that? Well, that would be negative infinity all the way up to 0, union 0 to infinity. So we're saying all real numbers except 0. What does the graph of this natural log x squared looks like? Well, if I put in a 1 squared is 1, natural log of 1, the answer log problem is the exponent is 0. How about if I put in an e squared, natural log e squared? What is the answer to a log problem? It's the exponent. Of course, the exponent is 2 there. And I get the commensurate or the reflection over this x equals 0 axis. I can choose any x for this particular problem besides 0. That's why we still have this vertical asymptote, this no-fly zone, if you will, on the y-axis, which is the equation of this y-axis is x equals 0. There's our vertical asymptote. Here's a very interesting one. How about finding the domain of the natural log of the absolute value of x minus 2? Of course, mechanically, we can say, well, where does x minus 2 have value greater than 0? Remember, for absolute value, if it's positive, keep it positive. If it's negative, make it negative. So almost always we're going to have a value greater than or equal to 0, except, what about if x is 2? We'd have 2 minus 2 absolute value, and that would be 0 greater than 0, which is not true. So the only value we'd have to exclude is, we'd say, domain is all real numbers except x cannot equal 2. And I encourage you to take out your graphing calculator and graph that and see for yourself that you're going to have a vertical asymptote at x equals 2 there. If we're going to do that in interval notation, it would be negative infinity to 2 union 2 to infinity for the domain there.